Somewhere out there, spinning around the corpse of a star that already died, there is a planet shaped like a lemon. Not round, not oval in the gentle way a rugby ball is oval. Stretched, pointed, deformed by forces so violent that nothing in our solar system has ever looked like it. And that is just the beginning. Before this video ends, you will see a planet raining rubies, a planet reflecting light like a mirror, a planet being eaten alive by the star it orbits, and a moon, drifting alone in permanent darkness, that might be able to hold liquid water for longer than life has existed on Earth. How is any of this possible? Let's find out. Start with the lemon. Its name is PSR J2322-2650b, and it doesn't orbit a normal star. It orbits a pulsar. Picture the mass of our entire sun crushed down into a sphere the size of a city, spinning so fast that it flashes like a lighthouse dozens of times a second. That is a pulsar. It is what's left over after a massive star collapses and dies. And close to this dead spinning core, gravity behaves in ways that would tear apart anything built like Earth. In December 2025, the James Webb Space Telescope turned its instruments toward this system and confirmed something astronomers had only suspected. The gravitational pull from the pulsar is so extreme that it stretches this Jupiter-sized planet out of its natural round shape and into something closer to a lemon. But the shape wasn't even the strangest part of the discovery. When Webb analyzed the planet's atmosphere, it didn't find water vapor, it didn't find methane, it didn't find any of the familiar chemistry astronomers expect to see on a giant planet. Instead, it found an atmosphere dominated by helium and carbon, a combination that has never been detected on a planet before. Deep beneath that strange atmosphere, under pressure almost impossible to imagine, scientists believe that carbon could be crushed into diamond. The lead investigator on this discovery, Michael Zhang of the University of Chicago, described it simply. This is a new type of planet atmosphere that nobody has ever seen before. But here's the detail most people miss entirely. This same planet has another secret. The pulsar it orbits belongs to a category astronomers call a black widow pulsar. And the name is not poetic exaggeration. It is a literal description of what is happening. Long ago, material from a companion star began flowing onto the pulsar, spinning it up and fueling a violent stellar wind. That wind, combined with intense radiation, is now slowly stripping material away from the smaller object nearby, the very planet Webb just photographed. Piece by piece, the pulsar is consuming it, like a spider feeding on prey caught in its web. The planet completes one full orbit around its killer in less than 8 hours. A planet shaped by gravity into a lemon, made of chemistry never seen before, slowly being devoured by a dead star. And that is only the first stop on this journey. Now travel outward, to a system where the very idea of a planet's orbit gets turned on its head. In April 2025, a team led by Thomas Baycroft, a PhD student at the University of Birmingham, announced something that had never been confirmed before. A planet orbiting not one star, but two failed stars, known as brown dwarfs, and not in the flat disk-like plane you would expect. This planet, called 2M1510, ABB, circles above and below the poles of its two stars, in a polar orbit unlike anything previously confirmed. Here is what makes this discovery remarkable. Nobody actually saw the planet. Using the Very Large Telescope in Chile, the team noticed something odd. The two brown dwarfs were wobbling. Not in the smooth, predictable way two orbiting stars should wobble, but backwards, in a pattern that made no sense unless something invisible was tugging on them from an unexpected angle. That backward wobble was the fingerprint of a hidden planet, one whose gravity was pulling the system in a direction nobody expected. It is the first confirmed case of a planet orbiting two stars at once in this sideways configuration, and it was found not by looking at a planet, but by noticing that two stars were moving wrong. If a planet can orbit two failed stars sideways, what about a star that shouldn't be able to host a planet at all? Meet TOI 6894, one of the smallest stars ever found to host a giant planet. It has only 20% the mass of our Sun. According to everything astronomers understood about how planets form, a star this small and faint shouldn't have enough material in its surrounding disk to build something as large as the planet that turned out to be orbiting it. But in June 2025, Nature Astronomy published the confirmation. TOI 6894b is a giant planet, transiting the lowest mass star ever known to host one. The planet is 40% the diameter of its own star, by far the highest planet-to-star size ratio ever observed. Picture a planet so large relative to its sun that every time it passes in front, it blocks out a staggering portion of the star's light. The lead author, Edward Bryant, didn't stumble onto this by accident. He searched through data from more than 91,000 low-mass red dwarf stars before he found the one star that broke the rules. To this day, no existing model of planet formation can fully explain how TOI 6894b came to exist. Some planets defy the models that are supposed to explain them. Others defy your expectations of what light itself can do. You've probably heard of WASP 76b before. Most people have. It's famous for its iron rain, molten iron evaporating on its blistering day side and condensing into liquid metal droplets on its colder night side. But there's a detail almost nobody talks about. In April 2024, scientists announced they had detected something on WASP 76b that had never been seen on any planet outside our solar system: a glory. If you've ever looked out an airplane window and seen a small, perfect ring of rainbow light surrounding the shadow of the plane on the clouds below, you've seen a glory. It's an optical phenomenon that requires very specific conditions. The particles in the atmosphere have to be nearly perfectly spherical, remarkably uniform in size, and stable enough to be observed consistently over time. After 23 separate observations spread across 3 years, the research team detected a sharp, telltale increase in brightness at one edge of the planet, the exact signature a glory would produce. Somewhere in WASP 76b's violent, iron-raining atmosphere, something is forming clouds so perfectly round and so perfectly uniform that they are bending starlight into a rainbow. What that substance actually is remains completely unknown. If WASP 76b can bend light into a rainbow, another planet takes reflection to an extreme that has never been matched. LTT 9779b reflects 80% of the light that hits it. That makes it the shiniest planet ever discovered, anywhere. The reason lies in clouds made of metal and silicate, materials that act almost like a mirror wrapped around the entire planet. But here is the part that changes everything. LTT 9779b sits in a region astronomers call the hot Neptune Desert, a zone so close to its star that planets like it are expected to have their atmospheres blasted away entirely. And yet this one survives. Scientists now believe its blinding shine isn't just a strange side effect. It might be the very reason the planet still exists. Those reflective clouds bounce starlight away before it can heat the planet to the point of destruction. And because the clouds are so metallic, the atmosphere itself becomes heavier, harder for stellar winds to strip away. In other words, this planet's shine isn't decoration, it's armor. Now for the planet everyone thinks they already know. You've probably heard that it rains rubies and sapphires on HATP 7b. Most videos stop right there, as if that sentence alone explains everything. It doesn't. Here's what actually happens. The clouds on HATP 7b are made of corundum, the mineral that forms the foundation of both rubies and sapphires here on Earth. On the planet's scorching day side, temperatures climb past 2,500 degrees Celsius, hot enough to vaporize that mineral completely. As it moves toward the cooler night side, it should, in theory, condense and fall as precipitation. But don't picture sparkling, cut gemstones falling from the sky. Research led by David Armstrong of the University of Warwick's Astrophysics Group found that the storms on this planet are so violent and unpredictable that the condensation happens too fast and too chaotically to form large, clear crystals. Instead, the planet likely produces micro-sized crystalline grains, closer to gritty dust than jewelry. That same research, published in December 2016, revealed something else remarkable. The winds on HATP 7b don't blow steadily in one direction the way you might expect. They reverse. Entire cloud systems surge one way across the planet, then shift back the other way, again and again, in a pattern of atmospheric chaos that would make Earth's most violent hurricanes look like a gentle afternoon breeze. It was, in fact, one of the very first weather forecasts ever produced for a planet outside our solar system. Astronomers using NASA's Kepler Space Telescope weren't just describing a planet. They were forecasting its storms, the same way a meteorologist forecasts a hurricane back home, except every forecast on this world ends in catastrophe. Sometimes the biggest discovery isn't a strange planet. It's proving that a planet exists at all. For over a century, Barnard's star, the nearest single star to our Sun, was considered a dead end. In 1963, astronomer Peter van de Kamp claimed to have found a planet orbiting it. Decades later, that claim collapsed. The wobble he detected wasn't a planet at all. It was vibrations in his own telescope. For generations afterward, Barnard's star carried a quiet reputation. The star that fooled everyone once and might never actually host a planet. In March 2025, that changed. Astronomers confirmed not one, but 4 small planets orbiting Barnard's star, each only 20 to 30% the mass of Earth. These planets orbit so close to their star that a full year on any of them lasts only a matter of days. One of the 4 is now the least massive planet ever discovered using the radial velocity technique, a method that detects planets by measuring the tiny gravitational wobble they cause in their star. What makes this confirmation so convincing is how it happened. 2 separate research teams, one working in Chile, one in Hawaii, arrived at the same conclusion completely independently, without coordinating with each other. After 100 years of false alarms, the same 4 worlds showed up in 2 different sets of data, gathered by 2 different telescopes, analyzed by 2 different teams who had no idea what the other was finding. Not every fascinating planet needs a star at all. Some planets get ejected from their solar systems entirely, cast out into the cold, empty space between stars with no sun to warm them. Astronomers call these rogue planets. You might assume that anything orbiting a rogue planet, any moon caught in its gravity, would be a frozen, lifeless rock forever. A team from Ludwig Maximilian University of Munich and the Max Planck Institute for Extraterrestrial Physics found something that overturns that assumption. When a rogue planet is violently ejected from its system, its moons don't settle into calm circular orbits. They get thrown into long, stretched, elongated paths instead. And on every single loop around their planet, these moons are squeezed and flexed by gravity, a process called tidal heating, converting mechanical stress directly into internal warmth. If that moon also has a hydrogen atmosphere, that atmosphere can act as an insulating blanket, trapping heat through a process called collision-induced absorption. The result? Liquid water, kept warm and stable, on a moon that receives no sunlight at all, drifting through total darkness between the stars. According to the research, published in February 2026, these moons could maintain that liquid water for up to 4.3 billion years. For comparison, that is longer than it took complex life to evolve here on Earth. Somewhere out in the endless dark, far from any star's warmth, there could be an ocean that has been liquid, stable, and waiting for longer than life itself has existed. Think about everything you've just seen. A planet stretched into a lemon by a dead star that is slowly eating it alive. A planet orbiting 2 failed stars from an angle nobody thought possible. A planet too large for the tiny star it circles. A planet bending starlight into a rainbow. A planet so reflective it survives by literally shining its way out of destruction. A planet raining gritty crystal dust in storms that reverse direction without warning. A star that fooled scientists for a century, finally proven to hold not 1 planet, but 4. And a moon, alone in the dark, that might hold an ocean older than complex life on Earth. None of these worlds look anything like home. None of them follow the rules we once thought applied everywhere. And that is exactly the point. Somewhere out there, spinning around the corpse of a star that already died, there is a planet shaped like a lemon. And it is only one of the strangest things the universe has ever built.